Hi, everybody. We're going to look at the final review, and I'm going to go through some of the first few questions. Let me get my camera up here so you can actually see me if you want. This first one, it says a rectangular prism pyramid has a height of 6 inches. It's got a side, one, or a length and a width. I guess I'll call it length and width. And this is my height. And you should know that the volume of a pyramid is equal to 1/3 base times height, where B is the area of the base. And the area of this base is length times width. So clearly, this is 20 square inches down here. We could substitute that in like that. And of course, the rule that I've always asked you to follow, and you should know the 5 problem solving steps. We have a labeled diagram, we have a formula, we substitute inside parentheses, and then we simplify. And in this particular case, I'm going to take 1/3 times the length, which is 5, times the width, which is 4, times the height, which is 6, and this is going to be in cubic inches. And when I simplify this, I can literally simplify it in my head. 3 goes into 6 2 times, and I just multiply it, and I get my answer. And of course, you should know what that answer is. Remember to write it in cubic inches. The second one says it's a square pyramid, and we need to realize that the base is how we're defining what kind of pyramid we're looking at. This up here is a rectangular pyramid because the base is a rectangle. This one is called a square pyramid because the base is a square. And of course, that means that this is 60 feet. The big problem here is that, well, we'll start with volume because volume we can do. The volume you can find. It's 1/3 the base times the height, the area of the base times the height. The area of the base is the area of this square, and you multiply that by the height, and you take 1/3 of that, and you should be able to find your volume in cubic feet. This is a really, really big pyramid. Now, when you unfold this thing, we are going to be able to find the surface area. And the surface area of a pyramid looks something like this. You've got the square in the middle, and then you've got these really tall, skinny pyramids out here. The problem is that we need to know how tall are these pyramids, these triangles, excuse me. And it's this length right here on all of these. And notice that the length is actually on the triangle. Well, this height is not on the triangle, it's inside of the pyramid. So what you're missing is this length and this distance right here. And it's called the slant height, and we almost always use L to represent it. This is the slant height for this pyramid. Now, the problem is, of course, that we have a right triangle that defines this thing, and they didn't tell us directly what it was. They said that this height right here is 120 feet, and hopefully you can see that this is halfway across, so we should know that this piece right here is the 30 feet. And if you use Pythagorean theorem, a squared plus b squared is equal to c squared. This is the hypotenuse of that right triangle. And we've seen this before, but you may have forgotten. And you have to substitute into the Pythagorean theorem to find this. In this particular case, my A is 30. My B is the 120-foot height. And my C is the slant height, that L. I'll put it in red so you can see it. And of course, you're going to have to square the 30 squared. That's 30 times 30. And you're going to have to square the 120 and square that. Add these together. And then, of course, for the last step, you have to take the square root. Now, that's going to give you an estimate for your slant height. So you're going to get an estimate for slant height. And you'll get an answer, and you'll get a decimal or something. And in order to find the surface area, you're going to have to find the area of all 4 of these triangles. They're all the same size. They all have a base of 60, not the base of the pyramid, the base of the triangle. The base of the triangle, and I like to use little b for that, and this is the height of the triangle. And there's 4 of those, and then you still have the square. So anyway, there it is. This number 3, and hopefully you'll find it. Number 3, we've got a truck that was hauling some sand, and it dumps the sand into a cone-shaped pile. And we've got this cone-shaped pile of sand. They told me that the height is 6 feet. And again, I like to use capital H for height in 3 dimensions. Now, the problem is they want me to find the diameter. I can't find the diameter directly, but what I can do is write the formula for the volume, because they did tell me that the volume is 136 cubic feet of sand. And so I know what the volume is, and the volume of a cone, hopefully you remember, is equal to 1/3 the area of the base, which is pi r squared, times the height. Well, notice that there's an r in here, and I can find that missing r if I know the volume and the height, and I do. The volume happens to be 136 cubic feet. I want to go through the steps one more time. I have a labeled diagram. I'm going to go ahead and call this, I guess I could put it in blue. There's my radius. If I knew the radius, then I would know the diameter. Well, I have a label diagram. I have a formula. I'm going to substitute 136 for the volume of the cone-shaped pile. That's 1/3 times pi. This is approximately 3.14, or you can use the pi key. R squared, and h happens to be 6. Well, to make it easier on myself, if I want to put this in the calculator, I certainly can, and get an estimate and divide it, and then take the square root. But take a look. 6 simplifies with 1/3 and just gives me the 2. So I'm going to divide by 2 pi on both sides. I'm just doing simple algebra. The pi's cancel and the 2's cancel. And I end up with r squared. This is about 6 point something, and it looks like you're going to get something like 22. Anyway, I'm going to have to take the square root of this when I get it, and then I'm going to find my radius, and then I still have to find, and this is going to be in feet, and I still have to find the diameter because that's what they asked for. Don't forget to answer the question asked. So don't forget to find the diameter in feet. So there you have it. You're going to take your 136. You should know why you're doing what you're doing. Find your radius, and then double it for the diameter. 2 cylindrical cans with the same height have radius of 2 and 3 inches. So we got the same height. We've got these 2 cans. We've got one of them has a radius that says it's 2 inches. And then we've got another one that's the same height, but this one, I'll make it a little bigger. It's a little bigger around, but it's the same height. It's supposed to be the same height. So they're both h for height. This one has a height of h. They don't specify what the height is. Sorry, I was getting in the way of my diagram here. And this one has an h height as well. They're both the same height. That's why I put h there. And this one has a radius, though, of 3 inches. It's a little bigger. And I'll call it capital R for the bigger radius. And it says the capacity of the smaller can. That's the volume. Well, the volume of the smaller can is equal to the area of the base times the height. Man, that sounds familiar. Pi r squared times the height. Well, I know the volume is 0.5 gallons. And pi is about 3.14, or I can leave pi there. And the radius is 2 times the height. And that says that my height, and this is in gallons, Well, I would have to know gallons into cubic inches if I wanted to actually solve anything with this. But it says, what is the capacity of the larger can in gallons? So this is in gallons. And what I can do is I can solve this for H and get how many gallons the height represents. Well, what I can do then, and I'll get a number. And what I can do is put it into this equation over here. The volume is equal to pi, and this time it's the big R, squared H. Now, the way that they want you to do this is they want you to figure out what the ratio of these two volumes is. And here's how this works. This is pi times 3 squared times H, and this is the volume. And we have a ratio of volumes that we could write for this. This one is 4H, this one is 9H. That's the ratio, 4 to 9. And then I could use it to solve for how many gallons this is. This is a decimal, and it just so happens that I could solve this for H in black, and it's going to give me gallons per square inch or something for my H, which is kind of weird. And then I could substitute it in here, and it'll give me my gallons because it'll cancel out the square inches. Anyway, lots of possibilities for this. Try one or the other. I'll give you a hint. This one has a multiplier of 4, and this one has a multiplier of 9. So the ratio of the volumes is 4 to 9. And you could write it that way too. This represents 4, and 9 represents what? So hopefully you can get it with a ratio or by doing my weird solving for H. Number 5, which is closest to the volume of the cylinder below? Now, I like to do both the exact value and the approximate value. So the volume, of course, of a cylinder is equal to pi r squared H, of course, area of the base times the height. I'm going to substitute in my values. I've got pi, I've got a radius of 2 inches, I got a height of 5 inches, and my exact value will have this symbol in it. And then you can get an approximate value as well. This is going to be in cubic meters. And there you go. You're just solving it. Way too easy. All right. If the circumference of a cylinder is known, how far around the cylinder? Hopefully this brings back memories of when we put the two cylinders, one of them from the paper going this direction, and then the other cylinder going the paper this direction. They have different circumferences. And if you know the circumference, then you also know the diameter. Because the circumference of this is the diameter, the circumference of any circle is equal to pi diameters. That's always true. What other information is needed to find the volume of the cylinder? So if you know the circumference, you can find the diameter, and then you'll know something else. And what you don't know is what they're asking for, is what else you need to know. You could actually do an example and work it out. All right. Had enough time there. That's the first page, and I'll get the second page in a different video. Bye, guys.